So we have already learned what do you mean by a relation. For example, here you can see that a relation R1 is defined from the set A to the set B. I call it as R1, and R1 is written down in the roster form. So the image of 1 is, you can say it is, image of 1 is B, or equivalently we write that the ordered pair 1B is in R1 and the image of 2 is A, so it is ordered pair 2A. And what is the domain of this relation is domain equal to the set of all first elements, or it is set 1, 2. And what's the speciality of the elements of A is that every element is not having an image. The element B does not have any image. So the element C has no image. No image. Come to this question here also. Every element of A has got image or not. You can just check it. This is your A, this is your B. The elements of A are set 1, 2, 3. And you can see that the image of 1 is B, the image of 2 is A, 1 comma B, 2 comma A, and also 2 has one more image. 2 has one more image, that is C. So what is the speciality here is that the element 2 has got more than one image, or you can say that image of 2 is not unique. Not unique. That means 2 has got more than one image. Now come to this third relation, which is defined from A to B. This relation R3, what is the speciality is that every element of A has image, and second is that the image is unique. The image is unique. So such type of relations are known as function. So what, now why R2 is not a function? Sorry, R1 is not a function. The two conditions you just check and see. The two condition means every element of A should have the image. But here we can see that the element 3 of A has no image. So R1 is not a function. R1 is not a function. Not a function because the element 3 of A does not have an image. R2 is not a function. Why? If every element of set A has got one and only one image in B, and the set, suppose F is defined from X to Y, the first set we call it as domain of the function, and the second set we call it as codomain of the function. The function is said to be a real function if the domain is real numbers or a subset of real numbers, and the codomain or range is also a set real numbers or a subset of real numbers. We will learn now identity function. So I define from R to R. So this first one is, first set we call it as domain of the function f, and the second set we call it as codomain of the function. Then the set of all images is called the range of the function. So R can be defined to a range also. Range means set of all images. For example, See, suppose f is given like this in the roster form 1, 2, 2, 3, 3, 5. If f is given in this form, what will be the domain of f? Domain of f is nothing but the set of all first element, that is set 1, 2, 3. Which are the first element? 1, 2, 3. And what do you mean by range? Range of the function f is, it is just like the relation which you have learned. It is set of all second elements. Second element means it is coming the images. Set of all images. It is the image of 1 is 2, image of 3, image of 2 is 3, and image of 3 is 5. This is what called a range of the function. Then one more way of expressing the same concept. Suppose f is this function, we can also say in some other ways, that is, listen carefully, the image of 1 is 2. Under the function f, there is one more notation for this, f of 1 equal to 2. What is that? What is meant by f of 1? It is image of 1 is equal to 2. Okay. Next, image of 2 is 3. So we can write it as image of 2 under the function f. So we write image of 2 as f of 2. F of 2 equal to 3. That means image of 2 equal to 3. The third one we can say image of 3 is 5. So how will you write? You can write it as f of 3 equal to 5. So these are the different ways of writing the function or expressing the concept of function. So now my question is, you have to check whether the set given is a function or not. If just given the name or it is given as R1, this is a relation. A relation becomes a function under certain special conditions. You have to remember that the special condition is that every element of the first set should have a unique image. Here, when you are given this R1 like this, we are just supposing that R1 is defined from domain of this. That is, what is the domain of this is? You can see the domain is 2, 2, 3. So set 2, 3 we can write because 2 will not be repeated in a set. R1 is defined from 2, 3 to the range. What is a range? The range is the set of all images. So we can write it as 5, 6, 7. This is a function defined, relation defined, and you have to just check whether this relation is a function or not. For that, what you need to check, every element of this domain should have an image, and the second condition, the image is unique. So what is the image of 2? This is image of 2. Image of 2 means from here you will check. Image of 2 here is 5 and here also image of 2 is 6. So that means f of 2 can be 5, 6. So that means the image is not unique. Image of 2 is not unique because usko more than one element hai. Is not unique. So R1 is not a function. So I have used this notation f. You can also call it as f. So you can also call it as f. So these are only notations. F can also be a relation. So f is defined from 2, 3 to 5, 6, 7. But the image of 2 is not unique. 2 का image इधर 5 ही है, 2 का इमेज इधर 6 भी है. So the relation is not a function because the image of 2 is not unique. एक से more than one images है. So like that relation cannot be a function. Or in other words, if a relation is given in the roster form, if the first element is repeated, what is that? First element of each ordered pair, if it is repeated. See, you can see here 2, 5 and 2, 6. 2, 5, 2, 6. The first element is repeated. So immediately we can say this relation is not a function. Now comes, children, next is a real function. Real function means f is from, you can say R to R. R means real numbers. This also is real numbers. It is not necessary that always it is a real number. It can also be a subset of real number. Suppose f is defined from closed interval -1, 1 to the open interval 0, 1. You can see that closed interval -1, 1. This is a subset of, it is a subset of R. And this is also a subset of R. So this type of functions are also known as real functions. Now what do you mean by real valued function? The real valued function means real valued. Real valued function means only those functions whose images are real values. For example, suppose you are taking your class 1. Class 1 का value हम डाल दिया 5. Class 2, इसका value डाल दिया 10. So this can be a function. The first element of each ordered pair is not a real number, but the second element, the image, is a real number. So this is a real number. This is also a real number. This second element is also known as a function value. So this is also known as value of the function. So that is why if the value is a real number, we call it as real valued function. For example, if you are written like this, some picture, okay, इसका साथ 1 डाल दिया. Then another some picture, इसका साथ value 2 डाल दिया. Okay, so what is f of? So what is f of this picture? The value of this is 1, which is a real value. So this is what called a real valued function. Now we consider some famous renowned functions. Some specific function. The first one is known as identity function, and this function is defined from R to R, defined by f of x equal to x. So you always mind that a function is usually defined. When you define a function, there are two things you have to remember. How to define a function? Two things you have to say. Defined from where to where. This is very important. And such that how the images look like, that you write like this, such that f of x equal to x. So I am just, f is defined from R to R such that f of x equal to x. So you are taking the real numbers as a domain. Here the codomain is also real number. This is your domain. This is your codomain. And how element is how the image is defined. X का image इधर भी x होगा. So if you take from here the point 1, what will be the image here? इसका image भी 1 होगा. If you take the point 2, इसका image also here it is 2. So this is a meaning. And when the function is real functions, you can draw very smooth curve for graph. R to R such that f of x equal to x. how to draw graph. What do you mean by graph? Graph of f means all the points or all the elements of f, you mark it in the Cartesian plane. It is coming to the analytical geometry and you are putting all the points or all the elements in the Cartesian plane, you will get the graph. Or graph of f is set of all x and f of x. ये पूरा ये अगर plot करेगा then you will get the graph of the function. So for this one, if you take some of the elements of this particular function, what will be some elements only I'm taking? If you take 1, its image will also be 1. If you take 2, its image also will be 2 because image is defined in terms of f of x equal to x. This f of x equal to x. So, image of 1 is 1, image of 2 is 2. And if you plot these points on the graph, how the graph comes like 1, 1, 2, 2, 3, 3, 4, 4, all these are points. It's not only the integers, any real number you take, its image also will be the same thing. So, you can also have 3, 3. You can also have, if you are taking half. So this is a graph of the function of x equal to s. I'm using the Geogebra graph. So this is the graph. You can just see here. See which are the points I've taken. Here the point I've taken is 2, 2. Okay. Then 4, this point is 4, 4. All those points from f of x equal to x. If you take, you will get here minus 2, minus 2. All these points and here 0, 0. These are all elements of this function. Okay. 1, 1, 2, 2, etc. These are all elements. And these elements, if you plot plane, you will get this graph. And you can see that this graph passes through origin. It is making an angle 45 degree with the x-axis. And this function is known as identity function. This is known as identity function. Okay. What is the domain and range of identity function? The domain is R, range is also R.